Okay, so last time, if you remember, what we did was we've been working in chapter 6, okay? And basically there we were working with annuities, okay? In particular, there was this thing called the TVM solver, and you can actually access that through the link I sent just now. It's also posted on Blackboard. Basically, you can use it to when you're working with annuities, and today we'll see loans as well. I mean, if you do happen to have a graphing calculator, I think there's an app in there. The TVM, I think, is in there as an app. The book goes a little more into that, but again, I didn't want to require people to buy a graphing calculator, especially since they're not cheap. So I didn't think that'd be right. I know I was able to download on my on my phone a math app that basically gives you it gives you the same functionality as a graphing calculator on your phone. I think it's called G Calculator. Wait, darn it. Let me just get to it. I'm sorry. Where is it? There it is. No, I clicked it again. There it is. G.calculator, I think it's called. G.cal. There it is. It's not too expensive. You don't have to buy it, okay? It's only I mean, for me, it was only $6. I bought it for the iPhone. I think they have it for Androids as well. It's optional, though. But it does have that TVM app in there. Because again, it basically gives your phone the same features as a TI-83 calculator. I think that's, so yeah, that comes up. I mean, I did find a website that has the TVM. They're talking about TVM. I think it stands for time, value, and money. But the website I found was not secure. At least my browser said it wasn't, so I didn't want to share that with you because I don't want to take a chance of hurting anyone's computer. So, it's just something I wanted to say but what's nice, again, thanks to GeoGebra, someone wrote an app, and again, the link is in the chat. That is a TVM solver, so good with that. Those do come up in this chapter, mostly because we're working with annuities. Basically we left off with last time was a payout annuity. And we saw a savings annuity earlier. Essentially, you could think of a savings annuity as a retirement account. Sorry, I couldn't think of the word. The idea there is like you're working, right, at a job, and from each paycheck you make, a little bit of some money comes out and goes into that retirement account. You're making monthly deposits, in other words. Money that's in there earns interest. This compound interest we're dealing with as well. Okay. We actually did see compound interest in chapter 4, if I remember correctly, 4 or 5. I don't remember which one. I think it was 4. No, it might have been 5. I'm sorry. But basically, we have seen it before. But in that situation, we assume there was only one deposit, and we basically, after that deposit, made no others or withdrawals. And we assume the account did, whatever. We saw how much was in there later on. Here, we're assuming there are many deposits. So yeah, the formula gets a little more involved. The work gets more involved, but that's okay. That's expected. Then, once you retire, we have what's called a payout annuity, where we're making many withdrawals. The money that's in there is earning interest. Okay. So I did put this screen here mostly because it's in the book, but also but also because it helps us see when to use a compound interest when you just have that, when you have when to use annuity and payout annuity, mostly because the formulas are kind of different. What we are assuming is, since there's compound interest happening, we are assuming that it's compounded as often as we're making payments or as we're making withdrawals. So if we're making monthly payments, we're assuming the account is compounded monthly. If we're making monthly withdrawals, same idea, we're assuming it's being compounded monthly. That's mostly for convenience. I mean, I think with the TVM solver, you don't have to assume that. However, we are going to assume that though. Otherwise, the calculations get really involved. Okay. All right. So this is what we've done so far. Now we're going to see loans. If I can, there we go. Okay. You know, there are loans out there. I mean, we actually have seen loans very briefly in chapter 5. There, though, we were able to calculate the interest immediately, mostly because we assumed, well, we did not assume we were going to make monthly payments. Here, however, we will do that. So here, I guess it gets a little more realistic because we're going to assume we're going to make monthly payments to pay off the loans. And also these kinds of loans, I'm not sure if school loans do this, at least I'm not sure if they do. I know car loans are like this, but we're going to assume the interest is not calculated up front. So up front, you'll know the balance, that you'll know how much you'll owe in that sense, you know, the balance. But remember, there is interest that's calculated. You know, that's how lenders make money. However, that's not calculated immediately. Okay. It turns out there is a formula for loans. It's actually the same formula as a payout annuity. The book goes a little more into why that's true. But for now, let's take a look at an example just to get our feet wet, so to say. So let's assume we're going to borrow $1,000, you know, from a bank, from a lender, whatever. We're borrowing at 12% annual interest, okay? At a 12% annual interest rate. That's what we're assuming, okay? And again, just like I said before, we're going to assume the account, you know, so we're borrowing that money, okay? The balance, you know, the account is being compounded with the same frequency as we make payments, unless it's stated otherwise, okay? So if we're going to make monthly payments, it's going to be compounded monthly. Okay, now, also the payments and the compounding occur at the end of the month. That's what we're assuming as well. So this is a little bit different than what's in the book because the book starts at month 1, okay? But I'm starting at month 0. I think the book has a typo unless there's something I'm missing. But anyway, what happens is this. You know, we borrow $1,000, right? Okay, so now we owe that much. We haven't made any payments yet. Okay, also, since the interest, the annual interest, the APR is 12%, that means monthly, the interest is going to be 1%, the monthly interest, you know, 12 months in a year. Okay, so during month 1, okay, you know, there's $1,000, that's how much we owe. 1% of that is the interest. So at the end of that month, the interest is calculated and added on to the balance. But we also make our payment, our monthly payment. So in the end of month 1, the ending balance is $910, as you can see. Okay. Again, we made a $100 payment, but there's also $10 as interest. Okay. So that's what happens here. And then month 2, right? Same idea. $10, you know, the interest is calculated. It's again 1%. So it's $9.10. And we make our monthly payment. This is all happening at the end of the month. We end up with a balance of $819.10 at the end of month 2. And this keeps on going. I'm doing this for the first 4 months, okay? Again, the book starts at month 1, where I have month 0. So their month 2 is what I'm doing is month 1. It could be something I'm overlooking, or it could be a typo in the book. But to me, what I'm doing makes sense. So anyway, this keeps on going. I mean, we could do more calculations, for many more months. But what's nice is we don't have to, because there's a formula, okay, for loans, basically. Okay, but again, but this is just illustrating what's going on. Notice the interest is decreasing. The interest is decreasing per month. That's expected. And why is that? Because the balance is going down, right? The interest is a certain percentage of the balance, of the prior balance, that is. But since that's decreasing, the interest is decreasing. Now, this is something the book mentions. I don't know how often this is going to come up, but I feel better saying it anyway. Namely, the monthly payment. Notice how the interest is largest at the beginning. Because of that, the monthly payment, a higher portion of it will pay off interest in the beginning. So basically a higher proportion, or a higher fraction, maybe that's better, of the monthly payment is going towards interest in the beginning. As time goes on, since interest is decreasing, but the monthly payment is not, that means a lesser proportion of the monthly payment goes towards interest as time goes on, as you can see. Now, honestly, I don't know if that's going to come up again, but it's just something I wanted to point out, though. Well, it's mostly happening because the monthly payment doesn't change, but the interest decreases. All right. Okay, let me stop and get back to let me pause the recording.